Okay, just like we were doing in the last video, we're going to count up the number of valence electrons for nitrogen, hydrogen in this molecule and then put it together. Okay, so here we go. Here's nitrogen. 1, 2, 3, 4, 5 valence electrons. So nitrogen has 5, and hydrogen we know has 1, but there's 3 of them. So 5 plus 3 is 8. I'm going to put the nitrogen in the middle, and hydrogen's going to surround him. 1, 2, 3. And then I'm going to start putting dots in. And I do that around nitrogen so that he's got an octet and he's happy. And whoa, that works out really nicely because I have 8 electrons, 2, 4, 6, 8. Each hydrogen has 2. So another way to mark that is by having 3 bonds. Okay? Okay, great. So this guy, again, this is telling you you've got 2 hydrogens next to that carbon. And this carbon and oxygen are probably bound together too. Okay, so carbon has 4 valence electrons, oxygen has 6, hydrogen is 1, but there's 2 of them. So 4 plus 6 plus 2 equals 12. Okay, I'm going to put carbon right here, and I'm going to put hydrogen on each side of him and oxygen above him. I know this because I've done it before. If you have oxygen to the right hand side, again, it doesn't matter where they are, north, south, east, west, but it does matter that the carbon and the oxygen are bound together. Okay, so I'm going to do this. So there's 2, 4, 6 electrons, and I'm going to do that so that we can bind everything together. Now everybody has an octet. I've given out plenty of electrons. Let's see if we have 12. Make sure. 2, 4, 6, 8, 10, 12, 14. It's a problem, right? So remember, what we do is we say, nope, none for you, and none for you up here, and instead that becomes a double bond. So let me write that a little bit more clearly because I know that that's pretty stacked together. Didn't mean to get it so crushed. There's a hydrogen, there's a hydrogen. So that's what the Lewis dot structure looks like. 2, 4, 6, 8, 10, 12. That's how many we should have. The oxygen has 8 electrons, the carbon has 8 electrons as well. Okay. Now these start getting into a little bit more complex structures where we're dealing with carbon and hydrogen. So let's talk about something else. Carbon has 4 valence electrons. Another way to look at that is that carbon can bond 4 times. Because remember, if carbon has 1, 2, 3, 4 valence electrons, and it wants to have 8, then he has to have 4 bonds to get 4 more electrons. In the same way, nitrogen has 5 valence electrons, so he needs 3 more bonds in order to have a complete octet. Oxygen has 6 valence electrons, so it needs 2 bonds to get to 8. And the halogens and hydrogen have 7 valence electrons, or 1 if you're hydrogen, and it needs 1 more to get to its nearest noble gas. So that means that these bond 1 time, these bond 2 times, these bond 3 times, and these bond 4 times. So it makes sense that the thing that bonds the most is kind of in the middle. So when I start these problems, I'm going to start by bonding carbon to itself first, and then I'm going to put hydrogen around it. And I'm probably going to keep it as even as I can, although that's not necessarily always the case. So I'm going to put hydrogen here, hydrogen here, hydrogen here, hydrogen here. And you better believe this is absolutely some type of sort of puzzle that you've got to solve. Okay, Let's go and count how many valence electrons we had. So there's 4 for each carbon, but there's 2 of them. Hydrogen has 1, but there's 4 of them. So this would be 8, and this would be 4. 8 plus 4 is 12. Now remember, each line is 2 electrons. 2, 4, 6, 8, 10. We only have 2 more electrons, or 1 bond, left to make these carbons happy. Another way to think of them as being happy is having 4 bonds. The only way to do that is to have a double bond right there. Okay. Now, let's try the C2H2. In this case, we have a carbon here. We have a carbon here. The C has 4 valence electrons. There's 2 of them. That's equal to 8. And if we have hydrogen, it has 1 valence electron. There's 2 of them. 8 plus 2 is 10 valence electrons. I'm just going to make this nice and even. And I'm going to go through like that. We have 2, 4, 6. I'm showing that you can do this with dots. You could do this with lines if you want to. Okay. So 2, 4, 6, 8, 10, 12, 14. Way too many. Gotta put those in the middle. 2, 4, 6, 8, 10, 12. Still too many. See how I just scratch them out from the outside and do a double bond. So another way to look at this, hydrogen can only bond once, carbon bonds 4 times. So this carbon can bond 1, 2, 3, 4 times. This carbon binds 1, 2, 3, 4 times. By the octet rule, it has 2, 4, 6, 8 on this carbon, and this carbon has 2, 4, 6, 8. So they're the same. Okay. Now down here we're getting to bigger stuff. Remember, hydrogen has to go on the outside because it only bonds 1 time. So that means that I'm going to start by linking my carbons together. And let's see, if I'm trying to make this symmetric, I need more ends on the end. 2, 4, 1, 2, 3, 4. Ooh, we got a lot of hydrogen, so let's start putting them everywhere. Let's make sure that's right. 1, 2, 3, 4, 5, 6, 7, 8. Hey, that's right, good. We gotta have glue to put them together. Then we're gonna count and make sure that all these are correct. Okay. We had 3 carbons. Carbon has 4 valence electrons times 3, that's 12. Hydrogen has 1 valence electron times 8 is 8. 12 plus 8 is 20. So let's see how many electrons we used. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Guess what? It's perfect. That's awesome. Good job if you got all this. Thank you very much. Go try some more.